So in continuing with section 2.6, we're looking at proving angles congruent. So just to review from what we did in class, we proved that congruent complements theorem. So two angles are complements of the same angle, then they're congruent to each other, right? The same with, we also proved in the video theorem 2.2 or 2-2, congruent supplements theorem. If two angles are supplements of the same angle or congruent angles, then they're congruent to each other. Then you all proved theorem 2-4, all right angles are congruent, and theorem 2-5, if two angles are congruent and supplementary, then each is a right angle, right? So let's use some or all of those to practice some more proofs. So here we're given that segment AC is perpendicular to segment BC, right? So AC perpendicular to BC, and then we're given that angle 3 is complementary to angle 1. All right, and we're trying to prove that angle 3 is congruent to angle 2. All right. So let's start out by including our givens. So segment AC is perpendicular to segment BC, right, by given. And if you wanted to right there, you could say, okay, well, that means that angle ACB is a right angle. But I'm just gonna continue with the givens. I like to do just put all the givens in first. All right, so angle 3 is complementary to angle 1, and that's also given. All right, so now I'm going to say that since AC is perpendicular to BC, that forms a right angle. So I'm going to say that ACB, angle ACB, or let's say the measure of angle ACB is 90 degrees. All right, so I squeezed in that little measure of there. And so the reason I'm going to put there is definition of perpendicular, right? And also definition of right angles, right? Because the definition of perpendicular says that two lines form a right angle, and then the definition of a right angle is that the measure is 90 degrees. So, okay. All right. And then let's see, we know that angle 3 is complementary to angle 1, right? And we know that since this angle ACB is a right angle, we know that angle 1 and angle 2 have to be complementary, right? So because they have to add up to 90 degrees. So let's start with they have to add up to 90 degrees, right? The measure of angle 1 plus the measure of angle 2. And let me actually come back a little bit here. So angle 1 plus angle 2 equals angle ACB, right? And we know that because of the angle addition postulate. Okay, and then so with that being the case, we can say that the measure of angle 1 plus the measure of angle 2 equals 90 degrees, right? And we can just say substitution there, right? We substituted 90 for ACB, and then, you know, just the measures of 1 and 2, which we don't know. So substitution. Okay. All All right, and then next we can say that angle 1, or let's do angle 2, is complementary to angle 1, right? And the reason why is definition of complementary. Right? If two angles add up to 90 degrees, then they're complementary by definition. And so now we just we figured out that we have two angles, angle 3 and angle 2, that are complementary to the same angle 1, right? And so since we have that relationship going on, we can use theorem 2-3, right? So by theorem 2-3, congruent complements theorem, we can say angle 3 must be congruent to angle 2, right? Because they're complements to the same angle. So we proved what we set out to prove. One thing here maybe that I should add, or it might be a good idea to add, is that this angle 1 plus angle 2 is congruent to angle ACB, right?